In section 5.5, we talked about the multiplication rule and conditional probabilities. The first learning objective is determine whether a pair of events is independent or dependent. This is an important concept because the multiplication rule changes a little bit depending on whether events are independent or dependent. Independent events mean that knowing one event happened does not change the probability that the other event happened. Dependent events mean that if you know that one thing happened, that changes the likelihood that the other thing happened. So let's look at these examples. Part 1 says, rolling a 3 on a die and flipping heads on a coin. We would like to know whether these pair of events are independent or dependent. If I roll a 3 on a die, it will not change the probability that when I flip a coin, it lands heads. And so therefore, these two events are independent. Part 2, drawing a spade from a deck of cards or drawing a 2 from the same deck of cards without replacement. So that means I first draw a spade from the deck of cards and then I take it out. A deck of cards has 52 cards. When I take a card out, regardless of whether it's a spade or not, then I only have 51 cards, which changes the probability of drawing a 2. Originally, there were 4 2s out of 52 cards, and now there are maybe 4 2s, maybe 3 if the first card I drew was the 2 of spades, but out of 51. Doesn't matter what exactly happened, either way the probability changed, and so therefore these are dependent events. Part 3, drawing a spade from a deck of cards and drawing a 2 from the same deck of cards now with replacement. Now when I draw that spade, I put it back in the deck of cards and there are still 52 cards. So the probability of drawing a 2 has not changed, which makes these events independent. In part 4, randomly selecting a male Salt Lake Community College student and randomly selecting a male Salt Lake Community College staff. If I am randomly selecting the individuals, when I select one student and determine that it is a male, that does not change the probability that when I select one staff, that will also be a male, and so therefore these are independent events. Here's another example. A group of students were asked if they carry a credit card. The responses are listed below. Are sophomore and not a credit card carrier independent? The following parts will help you answer this question. Part 1. If a student is selected at random, find the probability that the student is a sophomore. Well, we can see from this table that there are 40 sophomores out of 100 total students. 40 divided by 100 is 0.4. Part 2. If a student is selected at random, find the probability that the student is not a credit card carrier given that the student is a sophomore. So now I have some information about an event that already happened. I'm telling you that the student selected is a sophomore, which means that I can limit myself only to those individuals in the sophomore row. Of them, there are 24 who are not a credit card carrier. So this conditional probability is 24 divided by 40. I'm conditioning on the event that already happened, which is selecting a sophomore. I can't do this one in my head, so I'm going to do 24 divided by 40, and that gives me 0.6. Part 3. If a student is selected at random, find the probability that the student is a sophomore given that he or she is not a credit card carrier. Now the information that I already have is that the student is not a credit card carrier. So I'll limit myself to the not a credit card carrier column. And in that column, 24 out of 43 are sophomores. So the probability is 0.558. I'll round to 3 decimal places. And finally, part 4, are sophomore and not a credit card carrier independent? Why or why not? Remember that independent events mean that knowing one event happened does not change the probability of the other event happening. Well, let's look at some of these probabilities that we calculated. We calculated the probability of just being a sophomore, which is 0.4. And then we calculated the probability of being a sophomore given that we knew something else happened, given that the student was not a credit card carrier, which was 0.558. Since those probabilities were different, 0.4 changed to 0.558 because we knew information about the other event. That means these two events are not independent.